Let's continue in section 2.1 with working with more relations, and in this part is trying to find if a graph, which is a relation, represents a function or not. And we'll use a very simple test called the vertical line test. The vertical line test states if any vertical line drawn through a graph intersects that graph at more than one point, then the graph does not define y as a function of x, or it doesn't represent a function. So simply we'll draw some vertical lines through our graphs and see what happens. So if I draw a vertical line through this parabola, any vertical line, how many times does this vertical line cross that parabola? One spot. How many times does this line cross through that parabola? At one spot. So this one is a function. The vertical line crosses at only one spot. Let's look at this ellipse. If I draw a vertical line through it, the vertical line intersects that graph at more than one spot, and when that happens, by the definition, this one is not a function. Let's look at this kind of squiggly line thing. Let's draw a vertical line through it, and when we do, we're noticing that a vertical line is intersecting at several points, so it's not a function. And finally, let's look at the line there at the end. If I draw a vertical line through this line, intersects at exactly one point, so it is a function. So that's how we can tell if a graph represents a function or not. Now that we know how to tell if a relation is a function, let's now actually work more with functions using our function notation. And function notation just involves using a symbol, f parenthesis x, which is read f of x, which means the value of the function evaluated at some number or some expression x. Let's take an equation that you're probably more familiar with, just a linear equation in the standard form y equal mx plus b, but we'll look at this equation y equal 3x minus 5. To put this equation in function notation, all we do is we replace the letter y with the symbol f of x, and the evaluation is all the same. So if we had y equal 3x minus 5 and we wanted to plug in a 0 for x, then we would just simply do 3 times 0 minus 5, make that calculation as a negative 5, and that would be our answer. If we wanted to plug in a 1 for x, it would be 3 times 1 minus 5, which would give us negative 2. Plugging in a 4, 3 times 4 minus 5, 7. And finally, plugging in a negative 5, 3 times negative 5 minus 5 will be negative 15 minus 5, which is negative 20. That's how it worked in our old notation. In the new notation with the f of x, it's the same thing. F of 0 just means to plug in a 0 everywhere you have an x. So it's 3 times 0 minus 5. Same answer. F of 1 means to plug in a 1 everywhere you have an x. 3 times 1 minus 5. Same answer. F of 4, plug in a 4 everywhere you have an x. Same answer. And f of negative 5, plug in a negative 5 everywhere you have an x. Same answer. So just two ways to note the same equation. We'll work back and forth with both of them, either a y equal or an f of x equal to. But the f of x and the y are interchangeable. So what we note about evaluating a function is we just replace x with the value in the parenthesis. Kind of a plug-in situation. So let's look at these three functions and let's make some calculations here. So first function is f of x equal x squared minus 3x. Let's go ahead and calculate f of 0, which from our investigation above says everywhere we have an x, we're going to replace it with what? A 0. So I have 0 squared minus 3 times 0. Oh, that calculation is easy. It's 0. F of negative 3. Let's plug in a negative 3 everywhere we have an x. Be careful with your signs here. Negative 3 squared is 9. Negative 3 times negative 3 is positive 9, so we end up with a value of 18. F of negative x means everywhere you have an x, plug in a negative x. Instead of an actual number, we're plugging in an expression. Negative x squared minus 3 times negative x. Well, let's just play around with the signs. A negative x squared is going to end up being a positive x squared. Negative 3 times a negative x is a positive 3x, so we're just left with the expression x squared plus 3x. Finally, let's look at f of z plus 3. So every x in this function f is going to be replaced with what? This quantity z plus 3. What's it going to look like? Z plus 3 with a what? Square, because the original function has a square, minus 3 times what? The z plus 3. Each x got replaced with z plus 3. Now here we get into some old algebra where we need to clean this up. So it's going to look like, foiling this out, z plus 3 times z plus 3, and distributing out the negative 3, minus 3z minus 9. Foiling this out, we get z squared plus 6z plus 9, plus my other two terms, for a grand total of z squared, looks like plus 3z, but let me go back and check that just to make sure. Z squared plus 6z plus 9 minus 3z minus 9, okay, and the two 9's cancel, so yep, there we go. So f of z plus 3 is this quantity here. Let's do some from the g and the h function. So let's go to g, and let's do g of negative x. So everywhere we have an x, we'll plug in a negative x. Actually, there's nothing else you can do with that. Just leave it as it stands. How about g of negative 4? Everywhere we have an x, we'll plug in a negative 4. Negative 4 plus 3, negative 4 minus 5. If we combine the numerator, we'll get negative 1, the denominator negative 9, so we end up with 1/9 as a simplified fraction. And let's check out g of 5. I'm running out of room here, so we'll just jump down to g of 5, which would be 5 plus 3 over 5 minus 5, which is 8 over 0. Aha, got a problem. Do you remember the rule whenever you have division by 0? It's undefined. So keep that in mind. Restrictions we should always keep in mind. Can't have division by 0. And let's do a couple over here in the h set. H of 2. We'll plug in a 2 everywhere we have an x. Square root of 2 plus 2, square root of 4, easy enough. What would h of negative x look like? Negative x plus 2, and can't do anything with that. H of m squared. Look like m squared plus 2, can't do anything with that. And h of negative 6, square root of negative 6 plus 2, square root of negative 4. Ooh, we got an issue here with this one. Since we're only working with the real number system and not the complex number system, this one is undefined. We'll work with complex numbers later, not for now. So not only can't we have division by 0, we can't take even roots of negative numbers. Keep these restrictions in mind. They're going to pop up often, and we'll refer back to them. Just remember, can't have division by 0, can't have even roots of negative numbers.